Good day everyone and welcome to this very first virtual class. It's gonna be a snapshot of the basic things you need to know in a certain lesson in math, and I'm your teacher, Mrs. Romelinda de Guzman. So today our topic is Introduction to Quadratic Equations, a topic in Mathematics 9. I enjoin you to listen well and stay till the end of this video for some surprises. I promise. So, are you ready? Let's start.
Okay, what we need to know about quadratic equations and what are these values of a, b, and c in quadratic equation. So let's first start with the definition of a quadratic equation. A quadratic equation in one variable, take note of the word one variable, is an equation that contains a second degree term and no term of higher degree. So from this definition, our lesson for today shall evolve. Alright, so the standard form of quadratic equation is this that you see on your screen. Ax squared plus bx plus c equals 0. And from this, we're going to reflect on the definition that it is an equation in one variable. So the variable is x. And it contains a second degree term, which is the first term that you see in the equation, the ax squared. And no term of higher degree. That's why you cannot see an exponent of more than 2. The succeeding terms, the next one is what we call the linear term. Why linear term? It's because the exponent of the variable x is 1. And then the third term is what we call the constant term. From this definition, we can now come up with basic knowledge on how to identify a quadratic from a not quadratic equation. Okay, so what you see on your screen is basically a graph from the first pages of your SLK for quarter 1. You have there 10 items, and each item you are going to classify whether they are quadratic or not quadratic. So we are going to reflect from the previous definitions that we have, we had a while ago, which one is of the second degree term and no term is higher than that. So let's see number 1. 5x squared plus 2x plus 4 equals 0. Yes, this is quadratic. So you're going to answer it Q based from the instructions. Number 2, if you're going to inspect, although you don't see the same arrangement, still you can see an equation in one variable, and that is variable x, and the highest exponent of the terms there is 2. That's why it is also quadratic. So Q. For the third one, you may at first glance classify this one as a not quadratic equation because you cannot see the second degree term right away. But when we are going to simplify by performing the operations indicated by this parenthesis, you will come up of multiplying x by x plus 4, which will give you an answer which is x squared. That's why this is also quadratic. Alright? For number 4, there's no way that you can simplify to come up with a second degree term. That's why it is not quadratic. For number 5, it is the same as number 3. That's why it is quadratic. For number 6, all right. Now, take note of the definition that it is an equation of containing a second degree term and no term of higher degree. This makes it not quadratic because of the term 4x cubed. That's why this is NQ for number 6. And then, also with, let us look at number 9. Number 9 is the same as number 6. That's why this is also not quadratic. And then, for number 7, okay, we can see that as quadratic because of x squared. Number 8 and number 10 are not quadratic because you can, in no way you can simplify further or you can perform any operation so that it will yield to an equation containing a second degree term. That's why this is not quadratic and that one is also not quadratic. There you go. So let's move on to the next one. Okay. All right, we go back to our previous definition a while ago. If you notice on my screen, I have intentionally come up with special colors for A. Wait. I have intentionally placed a special color for A, for B, and for C. Because this standard form of quadratic equation will tell you that the values of A, B, and C are real numbers. Again, I say it, they are real numbers. So that when you're going to substitute any number to this A, B, and C, you come up with a specific example of quadratic equation. And now, let's do that so you can learn further. Okay? Let's try to have an example. First example, let's have 3x squared plus 2x plus 1 equals 0. So by inspection, everything about the definition of quadratic equation, you can tell that it is really a quadratic equation. So we are now going to identify the values of A, B, and C. Why? Because in the next or succeeding lessons that you will have, these particular values are very, very important for you in order to solve for solutions, in order to come up with graph, in order to translate this quadratic standard form of quadratic equation into its vertex form to come up with some other applications in problem solving and also as prerequisite to other higher lessons in mathematics later. So, what is the value of A? Of course, the value of A here, A equals 3, right? Then B is 2, and then C equals 1. Did you get that? Next, let's have another example because that is very easy. You see, they were arranged from descending order from the second degree term to the first degree term to the constant term because it is written in standard form. Standard form. All right. Now let's have an example. Second example, maybe I can write this another equation as 3x squared plus 2x equals 0. What did you notice? There are only two terms on the left side of the equation because I intentionally delete the third term. Okay, and I also patterned it just like closely similar to number 1 so that you can compare. So from here we know that again we have a equals 3, this one. Why I keep on emphasizing this one? Because in my experience in teaching, sometimes students will have the wrong understanding that a is equal to 3x squared, which is not correct. That is not correct because what we are only after at when we're identifying the value of a is the numerical coefficient in the second degree term. Take note of that. Okay, and then b, for b equals, wait, b is equal to 2. And what about c? Because you are already done writing down all the terms on the left side of the equation, you cannot see any constant term. That's why it is 0. Okay. For that, let's continue so that you can have a clearer understanding. Let's have number 3. We have 3x squared plus 1 equals 0. So you can compare it with my second example. So of course, a is again equal to 3. We have b. What is b? As you see, b is the linear term. Take note of that. So it's not necessarily b the next term that you see closest to the second degree term. But b should be the first degree term, and you cannot see any first degree term in my third example. That's why it should be equal to 0. And then for c, as you see, there's a constant term 1. That's why c equals 1. All right. And then for my last example, so that you can come up with a full understanding of what are the first degree term, the second degree term, and the third degree term, and then the values of a, b, and c. How do you identify? Now let's have my last example for this particular concept. We have 3x squared equals 0. So from here, for this particular example, you cannot see any first degree term and the constant term. That's why, and the only thing that you see is the first term or the second degree term. That's why you have a equals 3. You cannot see any b, that's why it's 0, and then you cannot see any c, that's why it is also 0. Because in the definition, I forget to place in that definition that where it says in the definition ax squared plus bx plus c equals 0 is the standard form where a, b, and c are real numbers and a should not be equal to 0, which means a is not equal, should be a number not equal to 0, b can be equal to 0, and c can be also equal to 0. All right, so for that particular concept, we're done with that, and then next we're going to see my next example will be this one. What happens or how are we going to, okay, first I'm going to write first the equation. This is example number 5. We have 3x squared plus 2x equals 1. Okay? So obviously this is not in the standard form because the standard form has to be equated to 0. And here we have 1, not in proper place. Okay? Dapat umayos siya. So as it's not yet in the standard form, it is very proper that we're going to rewrite this equation in the standard form. So you have 3x squared plus 2x and then minus 1 is equal to 1 minus 1. So you have 3x squared plus 2x minus 1 equals 0. It's just like transferring this constant term to the other side of the equation, and we change the sign of that positive 1 to negative 1. And there you go. So that you have A equals 3, B equals 2, and C for this particular example is equal to negative 1. And then next, let's move on to number 6 example. I hope you can follow. I hope you're enjoying your learning with me. For example, I have 3x squared plus 1 equals negative 2x. Again, the same procedure that we do in number 5. We again arrange, put them on the proper places based on our pattern and the standard form, and then find for the values of A, B, and C. So, what we're going to do is, you have 3x squared minus, we have plus 2x plus 1 equals negative 2x plus 2x. Simplified 2, we have 3x squared plus 2x plus 1 equals 0. And there you go. Maybe we can, oh, not maybe, sure, we can now write down the A, which is 3, B, which is 2, and C, which is 1. There you go. All right. Next one, next example. Maybe I can erase this part. Okay. Next example. What if I have, this particular example is, okay, let's have my 7th example maybe. Yes, 7. 7th, we have x plus 1 multiplied by 2x plus 3, and it is equated to 0. Sure, you know from our previous discussion that that is a quadratic equation. By following and simplifying using the FOIL method, first terms 2x squared, outer terms plus 3x, inner term plus 2x, then last terms we have 3. Right? Have you forgotten your FOIL method? First terms, outer terms, inner terms, last terms, and then we get their products. So we have to simplify by combining similar terms. So you have 2x squared plus 5x plus 3 equals 0. There you go. So we're now ready to write down A equals 2, B equals 5, and C equals 3. All right. So that is how is quadratic equation done. We have given examples on what is quadratic equation and what is not a quadratic equation, and finding the values of A, B, and C. There you go, and you made it to the end of the video. Hooray for that. So for the surprise, I want you to be shared or be inspired with this quote from the Bible, you see, during this time of the pandemic, sometimes we long for a face-to-face learning with your teacher. It's because maybe you want to ask some more knowledge, you want to be enlightened more on the discussions, but because we are restricted to just staying at home and we find no one to ask for additional knowledge. But in Proverbs chapter 1 verse 7 it says, the fear of the Lord is the beginning of knowledge. Fools despise wisdom and instructions. That means to say that whatever we do not know, whatever things that we long to know, we have to seek the guidance from the Lord, and He will direct you to the right people to whom you are going to get those knowledge. And of course, He will also lead you to a more brilliant understanding of what is your lesson, whatever it is, whether it is English, math, or whatever lesson. So if you want to be knowledgeable, seek God and He'll teach you or guide you to understand your lesson, to understand its life significance, and to understand life itself. Good day. Thank you very much.